So this is now the Mac OS Electron client for the Learning app. And as I am also interested in computational neuroscience and neuroscience in general, let's start with the course Learning How to Learn, which is based on neuroscience principles. We are now in the course workspace and see an overview about the course we are in. And let's look at the chat sidebar.
Starting with attention and working memory bottlenecks. I will use the saved course state and walk through the next idea directly.
As we are in auto presenter mode, I don't have to input my turn now, but it will auto continue after 10 seconds, so it stays in presenter mode. List workspace, you can see or imagine this like an OpenClaw.
Your brain effectively manages a very small high-speed buffer for active thought, and learning is primarily a journey of managing what goes into that buffer and how efficiently you clear it.
So in the background, it navigates the workspace files, what assets have been generated, are there existing infographics, and use these now to generate me a main document, which is the basis for all learning.
This bottleneck exists because the prefrontal cortex can only maintain a tiny number of information chunks at one time. When incoming information exceeds this limit, the brain doesn't just slow down, it starts dropping details or relying on shallow, fragmented processing, which is why multitasking is physically unable to support real learning.
Now, the idea is that the presenter now starts explaining the whole topic by actively scrolling two sections or two specific infographics. We can also see at the end of each section we have checkpoints that ensure that the topics covered in that section are actually learned by the student, and the results of the quiz are immediately sent back or injected into the context of the tutor. It can also embed YouTube videos inline. Now it actually created us a infographic.
This infographic illustrates how limited attentional bandwidth filters incoming sensory data before it even reaches your working memory processor. Any distraction acts as an extra load on this system, meaning every notification or thought switch forces the brain to discard a portion of your current learning thread to make space for the interrupt.
But let's actually have a fast look at the document. So we see a different section explaining different things. As I said, the quizzes at the end of each section, we have infographics, we have explainer videos. This is react to video, so this is all generated on demand in real time. This section failed.
We are still setting up the explainer structure, so let us move directly to why multitasking feels effective when it is truly detrimental. You might feel you are learning while listening to music or checking messages, but in reality, you are constantly reloading your working memory, causing you to lose the contextual depth required to store information long-term.
In the background, it has access to the YouTube Search API, so it can pull up relevant videos for specific sections or topics, which I can then watch inline directly.
Welcome to the Huberman Lab podcast, where we discuss science and science-based
This
tools
constant
for everyday
context
life.
switching wastes massive amounts of mental energy, as the brain must frequently reconstruct the state of your previous task.
Now, based on how the agent responds, you see it was in presenter mode. It didn't ask any questions. So let's turn to conversation mode and enter the course again.
Let's start with attention
Now
and
we
working
also see
memory
one entry, the
bottlenecks.
microphone was
Quick
unmuted.
diagnostic. Can you explain why multitasking reduces learning quality rather than just speed?
Actually, no clue, I guess, because of attention shifting, but I'm just getting started in this course.
Welcome. Since you're just starting, let's anchor ourselves in the most fundamental constraint, your attentional bandwidth. Everything you tried to learn must pass through this narrow gateway, and most common study habits actually force you to treat that gateway like a revolving door. To see how this affects your retention, predict this, If you read a chapter while switching between your phone notifications and the text, why does your brain struggle to convert that incoming information into a stable, long-term memory?
Now, if you're in an environment where you can't speak or you can't have audio, you of course always can pull up the sidebar and use it like a chat assistant. But the interesting part here is that it's able to scroll around and bring me within this learning document to the sections we are currently discussing. So, yeah, I'm actually getting started with this course, but I'm just starting multitasking myths section, which seems very interesting to me. Could you tell me something about that?
Multitasking creates an illusion of productivity because your brain isn't actually processing two things at once. It's rapidly switching contexts. Every time you flip your attention back and forth, your brain incurs a switching cost, dumping the current context in working memory and reloading the previous one. I've added an explanation in the artifact pane about why this friction makes long-term encoding so much harder. Before we move to the next section, what do you think happens to the depth of the neural trace when you force your brain to constantly pay that switching cost?
So the idea is that we have one single document that will grow over time. It's ordered like by the level, so we have to start with understanding attention, sections built on top of each other. Um, we can also go to the course map, and here we can see kind of defined learning gates and the dependency map of this course. So the idea is in the end to build a personal learning system for us, which is then grounded in neuroscience principles. But to reach this phase, we have to go through the quality gates, and the agent will ensure that we only reach this state here by passing the quality gates or learning gates at the end of each topic. So they build on top of each other, the hierarchy here. So to reach level 2, for example, we have to pass quizzes, open-ended questions, whatever the agent decides, it needs to ensure and verify that we have really mastered and understand these both topics. Only then it lets us proceed to the next sections. Now let's have a quick look at the observability layer, which is always important when working with agents. So this is the most recent session now. You can see here the amount of tool calls it did, the token it spent, the cost it incurred us, the duration of the session, and so on. And of course then exactly all the tool calls, the timings to optimize the assistant on speed, for example, where the most time went. Here assistant play out, so this is text to speech, but in general reasoning window took the longest. And in settings we can then of course switch between the conversational presenter mode, change the model it's using, and some other stuff.